Hello, and welcome to our Digital Project 2 Semester 1 presentation. So, let's start. Our first part of the presentation will be about the adder. So, let me show it. So, let me simulate it real quick, as we can see here. So, as we can see here, the circuit simulated perfectly with no issues. Let's start with the timing table for the adder. So, as we can see here, we have three inputs and two outputs. Let's start with the inputs. When A is 0, B will be 1, Cin will be 1. The outputs will be the C out will be 1 and the S will be 0. Moving on, A is 1, B is 0, Cin is 0. So the outputs will be C out is 0 and S is 1. Moving on, A is 1, B is 1, Cin is 1, C out is 1, and S is 1. Moving on to our next part of the project, which is the 4-bit full adder. So, as we can see here, let me show you real quick. So, this full adder contains the adder that we created or I showed you a minute ago. So, let's simulate it real quick. So, as we can see here, the circuit runs well and perfectly. Let's move on to the timing table for the 4-bit full adder. So, as we can see here, we have a carry in, we have two inputs, and we have the sum and the carry out. So let's start at 0 to 10 nanoseconds. A will equal to 0010, and B will equal to 0110. The sum will be 1000, and the C out will be 0. At T is 10 to 20 nanoseconds, 10 to 20 nanoseconds, the A will be 1110 and the B will be 0100, with the sum being 0010 and a carry out of 1. This shows the flow of the circuit basically. To our third part of the presentation, which is the registers. Let me show you here real quick. So let me simulate it. And as we can see here, the circuit works well. Let's move on to the timing table of the register. As we can see here, we have clock, clear, X and Q, X which is an input and Q which is the output of the register at 0 to 10 nanoseconds basically. The clear will be 1 and the Q will be reset to 0000. At 10 to 20 nanoseconds, the clear will be 0 and the register will begin to load and hold the value of X rising from the edge of the clock. Here, Q follows X, basically. Moving on to our last part of our project, which is the 4 times 1 multiplexer. As we can see here, the circuit. Let me show you. The circuit ran well and with no issues at all. Let's move on to the timing table for the multiplexer. As we can see, here we have the values, and at 0 to 10 nanoseconds, the lines S1 and S0 will be equal to 00, and the input will be equal to 1001, and the output matches the input, which is 1001. Was all for our presentation for today. Hope you understood and enjoyed our presentation. Thank you very much, and see you later.